Good morning, children. Today we will discuss about SuperHeterodyne Receiver. SuperHeterodyne Receiver. Let us go with the presentation. Let us see SuperHeterodyne Receiver. This SuperHeterodyne Receiver, it is a modulation technique. It is one of the modulation technique. And here, what is heterodyne or heterodyne? Now, let us consider two signals which are having different frequencies. Let us consider two signals which are having two different frequencies, and the process of mixing these two signals which are having different frequencies, it produces a new frequency which is called heterodyning. That means heterodyning, it is a process of mixing two signals which are having different frequencies to produce a new frequency is called as heterodyning. Now, here in the name itself we have, that means heterodyne means uh, which is the process of mixing two signals with two different frequencies, and that produce a new frequency. And super heterodyne receiver, which is a modulation technique, and this super heterodyne receiver which converts every selected radio frequency signal to a fixed lower frequency. That means here it converts the selected radio frequency signal into a fixed lower frequency. This fixed lower frequency is called intermediate frequency. That means super heterodyne receiver converts the selected radio frequency signal into a intermediate frequency. Now let us see the block diagram of the super heterodyne amplitude modulation receiver. Block diagram of super heterodyne amplitude modulation receiver. And here we have different components. This is the receiving antenna, this is the radio frequency stage, and this is the mixer, this is intermediate frequency amplifier, which this is the detector, audio and power amplifiers, and here this is the loudspeaker, and here this is AGC, automatic gain control, and this is local oscillator. Now let us see one by one. And here this is the receiving antenna. First we will discuss about receiving antenna. Here the amplitude modulation signal transmitted in the form of electromagnetic waves when it receives. That means this receiving antenna, when it receives the amplitude modulation signal, the amplitude modulation signal transmitted in the form of electromagnetic waves. Here we can see. That means the amplitude modulation signal transmitted in the form of electromagnetic waves when receive the receiving antenna. Then it induces a small voltage in the receiving antenna. So here, whenever the amplitude modulation signal transmitted in the form of electromagnetic wave, the receiving antenna, here it induces a small voltage in the receiving antenna. Now let us discuss the radio frequency stage, or it is the radio frequency amplifier. So here it is a RF stage, or it is an amplifier which selects required signal. This radio frequency stage or the amplifier which selects the required signal, and it rejects all the other signals. This RF stage, it rejects all the other signals, only it selects the required signal, and it reduces effect of noise. This RF amplifier, it reduces the effect of noise. So here output we obtain the desired frequency signal, let it be Fs. This is the output frequency signal. That means here the radio, in the case of radio frequency stage or radio frequency amplifier, it selects the required signal and it rejects all the other signals, and it reduces the effect of the noise. And here, and the desired output frequency signal, let it be Fs. Let it be say Fs. Next we will see about mixer. This is the mixer. In the name itself we have here the mixer mixes the received input signals. That means here it receives two inputs. Here this is one here, one from the radio frequency amplifier and another from the local oscillator. So here, that means this mixer, it receives two inputs. That means the output which is coming from this RF stage, and the here input from local oscillator. That means here we have the mixer. Here we it receives Fs and F naught here. That means one from the radio frequency amplifier and another from the local oscillator, which satisfies the conditions F naught and is always greater than Fs. Here F naught is always greater than Fs. That means here F naught minus Fs. Fs here whenever the received signals receives by the mixer, here we have a condition f naught is always greater than fs. That means f naught minus fx. So here the mixer mixes these two signals. That means one from the local oscillator and another from the RF stage, and it receives these two signals and it mixes these two signals and generates the signals which are having the different frequencies. This mixer it mixes and it generates the different frequencies. That means it generates f naught, fs. Let us see here. So here it generates the frequencies. Here fs, f naught, f naught plus fs, f naught minus fs. That means this mixer it produces these four signals. And this is about the mixer. Now let us see the intermediate frequency amplifier or IF amplifier. So here out of the four frequencies produced, already we have seen F0, Fs, and the frequencies F0 plus Fs, F0 minus Fs. So here the mixer it produces four different frequencies. So out of the four frequencies produced by this mixer, and this intermediate frequency amplifier it selects a only the difference component. That means f naught minus fs component. This if amplifier it selects only the difference component. Here we have f naught minus fs. So this if amplifier it selects the f naught minus fx, and all the other frequencies are rejected by this if intermediate frequency amplifier. So this is called the, so f naught minus fs is called intermediate frequency. So this intermediate frequency signal is then amplified and provides most of the gain to the receiver. This IF signal amplified and provides most of the gain to the receiver. So here the sensitivity, selectivity of the receiver does not change with the change in the incoming frequency. So here it receives the four different frequencies, but the sensitivity and selectivity of the receiver it does not change with the change in the incoming frequency. Now let us discuss about the detector. So here the amplifier IF signal which we have, the intermediate frequency signal, here the amplifier IF signal is detected by the detector. That means here the detector it detects this IF amplifier to recover the original modulated signal. This detector detects this IF amplifier to recover the original modulated signal. So the signal is then applied to the loudspeaker. So the signal which detects by this detector it applied to the loudspeaker. Here audio and power amplifiers here. So it applied the loudspeaker here. Now let us see the AGC or automatic gain control. So we know that every amplifier has its own gain. Already we have every amplifier has its own gain. So higher the gain, better the amplification. Whenever we have the higher gain, we have the better amplification. So here this is the AGC circuit. It controls the gains of the radio frequency and intermediate frequency. That means here AGC it controls RF stage and IF amplifier stage. So this keeps the level of output voltage constant even if the input signal at the receiving antenna fluctuates. That means here automatic gain it keeps the level of the output voltage constant. So even the output signal as the receiving antenna fluctuates. Now let us discuss about the advantages of this radio frequency and this super heterodyne amplitude modulation receiver. So here the advantages behind this one, we have no variation in the bandwidth. We cannot observe any variation, no variation in the bandwidth, and it has the high sensitivity and selectivity. So here we have high adjacent channel rejection. So these are the advantages of this super heterodyne AM receiver. Now let us discuss about super heterodyne frequency modulation receiver, super heterodyne FM receiver. So here also we have the different components we have. Here we have receiving antenna, and here radio frequency amplifier. We have mixer, intermediate frequency amplifier. This is the limiter, FM detector, DE emphasis, AF and power amplification. So here we have the loudspeaker, and here AGC we have. So this is the local oscillator. Now let us discuss the RF amplifier. So here we have the receiving antenna. So let us. This is for frequency modulation receiver. And now let us discuss RF amplifier. So this RF amplifier or radio frequency amplifier, which is used in the frequency modulation receivers, which to improve the signal to noise ratio of a signal. So it matches the receiver input impedance with antenna impedance. That means here this RF amplifier, this matches the receiver input impedance to the antenna impedance. So which is required for good reception of the signal. Whenever we have the received input in the matching of the received input impedance with the antenna impedance, we have the good reception of the signal. So this is the radio frequency amplifier, which helps in matching the receiver input impedance with the antenna impedance. So that is the good reception of the signal. Now let us discuss about the mixer. So here mixer which mixes the signals. So here similar to the amplitude modulation receiver, the mixer stays in FM receiver also. So here this converts the received signal to the intermediate frequency signal. So it is carried out in a similar way as that of AM receiver already, which we have seen the same process here also. It mixes and it sends the output here, and here this is the intermediate frequency amplifier. It performs the same operation as in the case of AM modulation. So it amplifies the intermediate frequency to the desired level. So here when we compare to the amplitude modulation, here IF amplifier, the FM frequency modulation requires high bandwidth. So here IF equals to, here we will consider 20.7, and bandwidth here we will consider 200 kilohertz. So now let us see the amplitude limiter stays. Amplitude limiter stays. So here in frequency modulation, amplitude of the modulated wave remains constant. In frequency modulation, amplitude of the modulation wave remains constant. But practically, if we see the practically, when wave is transmitted, random noise and other unwanted signals get added to the modulated signal. That means here this limiter, what will happen here? Here we have, if we consider the limiter, here we have two cases here. So first one, it is amplitude limiter stays, ideal stays, practical stays. So if you consider the ideally, frequency modulation of the amplitude of the modulated wave remains constant. But if you see practically, when the wave is transmitted, random noise and other unwanted signals get added to the modulation signal. Therefore, what will happen? Amplitude becomes changed. So that amplitude changes must be eliminated before the signal which goes for the demodulation to recover back the original signal as it is. That means here this limiter, it does not allow the changed amplitude modulation signals. It before that, whenever the amplitude becomes changes, before that only it eliminated all the changes before it reaches the signal, and the signal goes for the demodulation to recover back the original signal as it is. So here amplitude limiter, it removes all the unwanted signals, and hence it is always placed before the FM detector. So why we are keeping this before the FM detector, this limiter? Because whenever the amplitude changes, it does not consider, does not allow that amplitude modulation change its signals. It receives before the change occurs in the amplitude modulation. So here this is the frequency modulation detector, which demodulates the frequency FM wave, frequency modulation wave. It demodulates the frequency modulation wave, and it extracts the information signal. Why we are placing limiter? So this limiter, it does not allow the change in the modulation signal. So it demodulates and it sends to the FM detector, and this FM detector, it demodulates the frequency modulation wave, and it extracts the information signal. So passing it via power amplifier, and then amplified to the loudspeaker. So the received signal which extracts the information signal, it sends to the loudspeaker. And here this AGC already we have seen, it controls this RF amplifier and limiter. And this is about super heterodyne frequency modulation receiver. Thank you, children.